Right. So when we talk about multicasting, these two protocols we cannot avoid. Multicasting is not possible without these two protocols. PIM, Protocol Independent Multicasting, Internet Group Management Protocol. Now, PIM is to distribute the multicast traffic, move the multicast traffic from source to the group member. And IGMP is to join a multicast group. So two things. First, group members need to enroll themselves. For that, they need this IGMP. And to take the traffic which the sender is sending towards the receiver's direction, towards the group member's direction, we need PIM. Now, this PIM is of two types. One is the dense mode. Not many devices supports dense mode now because it's not a good method of multicasting, dense mode, because it always floods and unnecessarily it floods and disturbs everyone. Even when there is no group member, the traffic is sent to them and they drop it. So because there is no one receiving it, it will prune. But it won't stop. Again, it will flood. Again, it will prune. It's like flooding and pruning, dense method. The other one is the sparse mode. Sparse mode and dense mode. Sparse mode is like the source and the group member meets in a one meeting point, which in French we call as a rendezvous point, RP. A rendezvous point is a router. You can make any router as a rendezvous point where this S will know about the group member and group member will know about the source. Because they can now know each other, there is no need for flooding. In the dense mode, source never knows about the group and group member don't know who the source is. So there is always need for a flooding. And whoever wants to take, they take it. Others prune it, others drop it, which is not good, which is not scalable. It's a CPU bandwidth highly consumption method. Sparse mode knows where the group members are. The source knows where the group members are through the rendezvous point. As a result, when a packet is sent, it goes only on those links where there is a receiver, not flooded on all over the topology. So sparse mode is what we see in most of the devices, high-end devices like Nexus. It supports only sparse mode. But iOS routers support both. But I have seen like latest devices, they don't keep dense mode anymore. There's only one option, sparse mode, because dense mode is not a right way of doing multicasting. Now, the default version of PIM is PIM version 2. There is also another version called 3, which is source specific multicasting. Source specific multicasting SSM. We'll talk about this later. And now, what about version 1? Version 1 has got some flaws. That's why we have version 2, and version 2 is default. Version 1 you don't need to worry about because it has got some flaws. So IGMP also got 3 versions. About this we will talk later, but slightly I'll touch now. Version 1, version 2, Version 1 is doing the same job what version 2 and 3 does, but the problem is when we use version 1 and join a multicast group, and when we are done, when we don't want to continue as a group member, there is no way to notify that I'm leaving. The leave message is not possible to generate in IGMP version 1. No leave message. As a result, the sender still thinks that I'm available to receive his packet, which is not good. IGMP version 2 generates leave message. Before leaving the group, it generates a leave message so that the sender knows that there is no more receiver there in that direction. Version 3 again, it works with PIM version 3 source specific multicasting supported in IGMP version 3. So we'll talk about these version differences in detail again later. Now, the whole multicast story is only this much. What we have a source and there are group members. And the group members may be in one single location, may not be also. They may be in multiple networks. Now, the whereabout of group member and the source is not discoverable, cannot be discovered in dense mode. In sparse mode, can be discovered through a mediator called RP. Because to RP, the source will go and register saying, hey, I am the source for this particular 239.111 address. So RP knows now who the source is. 1.1.1.1 router is the source. Now, if someone here joins the group 239.1.1.1, they also come to RP and say, hey, RP, I belong to this group 239.1.1. So kindly help the source to know about my location. So through RP, source will know the whereabout of the group member. So now source need not to go through RP anymore. It can deliver the packet directly, the multicast packet directly to the group member, which solves the flooding and pruning problem that we have. So this is the main story. The other story is how do we configure RP and inform the RPs whereabout to the group members and the source. See, if source and group member needs to come and register with the RP, they need to know where the RP is. For that, we have various methods. One goes statically configure RP on every route. Statically, we inform who RP is. The second method is Cisco's method called auto RP, in which we flood and discover RP. We are trying to avoid flood, but this auto RP is flooding and discovering RP. After discovering, you stop flooding. So not many people like it because it to avoid flooding, it uses flooding method to learn and then stops flooding. So this is not really a good one, but again, it's a Cisco's. The best one is bidirectional PIM. Sorry, but the best one is BSR, bootstrap route. This is the best method of, according to me, the best method of knowing RPs. So every router needs to know who the RP is. So instead of running some additional protocol, we can make use of the same PIM to announce. Because PIM is running everywhere, we make use of the same PIM to announce who RP is using PIM. So there is no additional overload. There is no need of another protocol. So this is one. There is another method called candidate RP BSR. I'll let you know. There is another method. And then that's one topic. I'll just give you the name after a few minutes when I remember. Next is
Sure.
we can have multiple RPs. If your network is too big, instead of keeping just one router, let's say I have 500 routers in my multicast environment, and if I need to have only one RP, if I have only one RP, then every router should come to that middle point to know about the source and the group, which is not good. Instead, I can keep RPs in various locations. I can keep RPs in various locations, and I can sync the RPs so that every group member and the source will go and register themselves to the nearest RP, and through that RP itself, they will know about the group members and source, because all the RPs are interlinked, synced using multicast source discovery protocol, MSDP. So MSDP is another protocol we learn here. The reason why we need this is when we have more than one RP, RP1, RP2,
Right.
to get synced. Otherwise, group member register to one RP. This is RP2. All the group member registers here, and then the source is close to RP1. Source goes and registers here. And then how now this source will know about the group member if this is not synced? This need to be synchronized. For that, we use MSDP, Multicast Source Discovery Protocol. So about these all, okay, there is also one more called bidirectional PIM. Bidirectional PIM. This is like anyone can be a source group member. There is no one particular source. Sometimes I'm a source, sometimes I'm a group member. Again, sometimes you are a source, sometimes you are a group member. So if you have, if the source keeps changing, instead of maintaining all the source information, we just only maintain the group members. We call it as bidirectional PIM. When we do a lab, you will understand this better. So all this is what we call it as multicasting. There is nothing more than this. We are going to see in detail one by one.
Wow. Very nice.
Let us, yeah, please, question.
Yeah. No questions. What I've got from you was, I've heard of this MSDP, but now I understand that it's to synchronize the RPs at different locations. The one closest to you responds, so you keep them nice and separate because the topology is too big, right? 500. Got it.
We also have Anycast RP.
Oh, you found the fourth.
Anycast RP. We
Anycast.
also have
Yes,
one
that's
more.
right.
That I still need to recall. It will take some time. I'll let you know. So all these things, when we cover and when we have hands-on, then we are good to go. So let's see one by one. I'm going to turn on the server. I have a small nook. Resume the recording. Okay, now router.
Before
It's recording
you,
now.
okay, go
Router
ahead. Router,
ISIS. You
ISIS.
even if you don't give a
Okay.
process name, it's okay. Or if you want to give, I can give like a multicast lab. Multi lab. So this is the process ID that I'm giving. It can be a number or name, or even if you don't give anything, it is okay. It's not mandatory to provide a process ID. And then the network entity title, it is equal to the router ID in OSPF. So what are all the things that we type in network entity title? First is we say whether it is private or public. 49 means private. And then we provide area ID. This is the portion of area. And then we provide system ID. Like if, okay, for example, for router 1, I want to give as the system ID. This should be unique. This need to be unique. And then the end selector should be 00 always, because IPv4 ISIS means 00. That's all, the difficult part. 49. And then to represent area, you got the bits,
Mm.
and you got 3 sets of bits to represent system ID, and last should be 00. Now I need to copy this and paste it to all the interface, putting IP in the front. IP router ISIS. That's it. IP router, sorry, IP, paste it. That's how we enroll this interface under ISIS. That's how we make this interface to run ISIS. That's it.
So
Yeah.
can you go back to the where you put net and then the 4900
Here,
just to see something?
1
I
byte
missed
is
something.
0 always. This is 1 byte.
Okay, I see, I see.
This is 2 plus 2 plus 2,
Mm.
6 byte of system ID. And then 1 to 13 bytes of area ID. But right now we are using only 3 bytes. You can even go up to 13 bytes. So totally you have, if this is 13, 13,
Mm.
14, 15, 16, 17, 18, 19, 20 bytes. 20 byte is the maximum size of network entity title, in which right now we are using 6 plus 1, 7, 8, 9, and 10 bytes. Out of 20, right now we are using only 10 bytes. If you want a big area ID, you can have up to 13 bytes, in which we have only 3 bytes right now used.
Mm.
Fine. So I call the ISIS process under these interfaces and write to memory. Finish. Router 1 is ready. Okay. Next is I also want to run multicasting. Okay, from the second router onwards, we'll do multicasting using Notepad. Right now, I'm going to paste only ISIS and IP address. I'll put this on router 1. Next is let me save this to a folder so that you can use it. You don't need to type all this thing.
Oh, very nice. Thank you.
R1 config. Fine, now let me save this as R3. Save as R3 so that I can do some changes and use it on router 3. So router 3, this will be 3 here, and this will be 3333. And this is going to be 3.3.3.3. And on router 3, 00 Ethernet will be 13.3. And 01 will be 12. Oh, this is not 12. This is 36. Dot 3 and this is 34. That's all. We are going to paste this now. And let's save this. 0 to 3. After I paste it, I'm expecting a neighborship, ISIS neighbor. Sure, ISIS neighbor. I can
Makes
see
sense.
L1, L2 neighborship has come. ISIS will form two adjacency by default, L1 and L2. L1 is adjacency within the same area. L2 will be done within same area as well as other area. Right now we don't have other area, so if I want to suppress this L2, I can do it, but that's not our area of study. We are not focusing much on ISIS here. So let it be there. No problem if I have two adjacents. What next? Let's go finish R4. R4 also got 3 interface. So let's finish R4. I'll save this as R4. 4 here. And this is going to be footer 4. This is 24.4. E1 is 34.4. E2 is 45.4. Again, I'm expecting IBGP neighbor, sorry, ISIS neighbor. Show ISIS neighbor. Yes. Next is router 6 also got 3 interface. Let me finish router 6. Now I want to add even multicasting to this. So that we need not to come back again to this notepad. Configuring multicasting, let's start from R1. Then we'll go to R6. I'm going to do multicasting manually on R1, R3, and R4. And for the remaining router, I'm going to use the same notepad. 3 routers we have already finished configuring, so I'm going back to those 3 routers and saying IP multicast routing. This is the command to enable multicast support on the router, which is not enabled by default. Secondly, I have to enable PIM on all the interfaces, either sparse mode or dense mode. Let's see dense mode first, including loopback. IPPIM. If you see the mode, IPPIM, you have sparse mode. We also have sparse dense mode, which means if sparse is not working, it will fall to dense mode. And we also have dense mode here. Okay, the one method that I was thinking about is okay, BSR is already there. Sorry, if I remember, I'll let you know. There is one more method. Okay, IPPIM dense mode is configured. So I'm going to use that same to show history. I'm going to put this in a notepad. And then the range. It's the same range of interface on router 3 and 4. And this two line is for 3. This two line is for 3.
For which router? Let's see. 3.
Done. Okay, the mode command.
Right, same range, you're right.
Dense mode. And this line need to be copied. So let me copy these 3 lines and put it on router 4. Right, so they discover neighbor. You can see 10.32.34.0. You can see now neighbor. When I go to router 3, I should see 2 neighbors. Show IPPM neighbor. There are 2 neighbors, router 1 and 4 are neighbor, in which for router 3, router 4 is a designated router.
Right.
The one with the bigger router is a designated router. And for router 1, router 3 is a DR. That's why you don't see here DR. Because router 3 himself is a DR for router, this link. Each link will have a DR, same like OSPF. Now, I was telling you the default PIM version is version 2. Right. Let us now go to router 6 and configure router 6. Router 6, I've got one more interface, so I put 3 here.
Right.
And interface with 0/3. IP address is 10.67.0.6. And then I need to also put this ISIS command. Okay, so Ethernet 02 IP address is 68.6 and interface 01 is 61.6 and 00 is 36.6. And the router ID, sorry, the loopback is 6.6.6.6. And this is correct, we just changed it. 61, 58, 67. Looks all good. Let us go and put it on the command line. Router 6. Now we are expecting another
Yes.
neighbor. Show IP pim. Show IP pim neighbor. Yeah. So this proves that you also got reachability. We are also able to ping. If ping is not happening, then this won't form neighbor. Show IP route ISIS. I have reachability to 1 network, 3 network, and 4 network. So routing is good. Multicasting is also good. Show IP pim interfaces. So all this this 4 or 5 interfaces, 4 plus 5 or 4 plus 1, 5. The loopback is running multicast. And the mode that it is running is dense mode, not the sparse mode. Sparse mode will have S, dense mode is D. Next. So far, we have finished 4 devices. Now let us
Right.
focus on interface, 2 interface routers. So let me start from router 2. Well, let's go to router 10. Router 10, let's finish router 10. Router 10. 10, 10, 10. That's it. And loopback. And Ethernet 00, 9110. And Ethernet 01, 6110. So 6110, 9110. Loopback and multicasting 1, just to interface. Let's put this on router 10.
Perfect.
Yeah. So going back to 10, let's paste this. Okay, router 10 is done. I'm expecting again neighbor. Show IP pim neighbor. We got the neighbor.
So not 9,
Show
right?
ISIS neighbor, of course it will be there. Show IP route ISIS. We got the routes.
Beautiful.
Now let us go back
Yes.
to the small number 9. And then the loopback will be 9.9.9.9. And Ethernet 00 is 19.9. Ethernet 01 is 91.9. And that's it. There is no other change. Same number of interface. Names are same. 9 is also ready. Okay, so next is router 2. Yeah, let's do router 2 configuration. ISIs won't be there in your exam. It's going to be OSPF in enterprises.
But it's good to know. It really is.
All right, that's it.
Right.
Let's put it on. Okay, now router 2 is also ready. What is left is 5, 7, and 8. They're all single interface routers. Let us start from 5. This is 45 and 5. That's all. Next. 7. Ethernet 00 is 67. All right. Now one more. Then we can start verifying things. So what breakfast you had, brother? Mhm.
Breakfast, probably
So is it lunchtime now?
eggs and
Close
noodles.
to lunch.
My wife had some noodles that she made, well, that warmed up, and then tea. It was good. Yeah.
Okay.
My
Okay. Understood.
It's
It's going to be midnight, 12
it's
o'clock, 3
past
minutes
lunch,
in few minutes,
but
12
it's
o'clock.
okay because I mean this
It's okay.
we had something
We
to
can
eat
do
earlier.
spas
Yeah,
mode
the breakfast we had
after this,
late
and then
breakfast brunch they call it. Yeah,
yeah.
yeah.
So the other methods of discovering
What
RP
time is it?
we'll
Is
see
it over
another
there
day.
now?
So we are doing dense mode now. After this, we'll do sparse mode.
Oh,
So dense mode is
it's late
configured
over there.
everywhere,
Oh, brother.
meaning the multicast support is not only
Yeah,
on the router, also in the
and wrap it
path.
up, I guess. Yeah, that's good. That's good.
Sparse mode is nothing but PIM mode. PIM is the protocol that is responsible to connect the source and the group member. We don't know where is group, we don't know where is source. Let us consider one of the router here as the source, and we can have some group members.
Mm-hmm.
So let us take R1 as a source. Source of what? R1 is a source of a particular multicast group, let's say. Anything between 224 to 239 is multicasting, we know. I'm going to use 239.101.1 R1 as the source. Right. In the real world, there will be some application connected to one of the computer working as a source. But here for testing, I'm going to use ping ICMP to generate some multicast traffic. Right now, there is no group member, so if I ping, I will not get any response. I'm generating a traffic using ICMP, sending to this group address 239.1.1.1. Who is going to respond? No one will respond. But actually, the packet is going to
Mm.
everyone. Everyone, including this tip of that branches, everyone has received the packet, but no one responded. No one responded. What is the proof? Everyone has received this packet. One is we can sniff using Wireshark. Let's see. Is it possible for me to do Wireshark? No. For GNS3, we would have, I think I can do it here. Yeah, capture. Capture on Ethernet 00.
Yeah.
Okay, so why nothing is coming?
Mm-hmm. Sure.
There should be some packet now. Layer 2, some packets. Let me try pinging again. Let me try pinging 1067. So nothing is coming, which means Wireshark is not working. Let's try again. Capture Ethernet 00. No. So Wireshark is not really merged with this tool. Let me try capturing here at least. No, not connected to this EV. What we can do is we can debug. Now this is the multicast address PIM users 224.0.0.13. Now let's try pinging.
Yeah. I see. Oh yeah, debug.
You see source, and you see the flooding is coming. Let me try showing again. The 239.111 will be the destination of the packet. There's only one packet sent, so you will see only one. But it is going very fast. I saw that.
Yes. Yes.
You see here the second line, third line, source from 1111, destination 239.111. Input feature, MCI, check, send yourself, forward check, false. There is no forward check. Fine. So, or if I repeat it 10 times, then you may see.
Right. Yeah, I saw it too earlier. 224.
It's flooding and pruning.
Yes.
It has pruned in the direction, but it will again try. Once it prunes, it will wait for a random period of time and again it will try. That's why we are not seeing now. It was there earlier and it has pruned. And we can verify in another place. If we go to router, if we go to this router where we were checking, router 6, let's go and check. It will show pruned.
Right.
Show IPM route. You can see that this to this destination coming from this source, it has pruned on G03, which is connecting to router 7. That's why you are not able to see. Pruning means, found that there is no one to receive, so I am not going to send anymore. But it won't be there for a long time, only for a random period of time. This will vanish from the table. And then when you ping again it will flood. See, it's gone now. Let me show you.
So sorry for this part I don't remember. So pruning is like filtering, removing.
It was sourced from router 1's address earlier. Earlier when I showed you.
Got it.
Okay. It was sourced from router 1's address, isn't it? Now you don't see that anymore. Now if I ping, definitely you will see that packet there. We were seeing here, right? Router 7. Now I'll go to router 1 and ping again. You will definitely see it here. You see? 239.111. It's coming many times now.
Yeah, that's right there.
Until it decides as pruning. See? Here are 2 times. See here 2 times.
Very
So this is
nice.
why we call this flooding and pruning. This is not really a recommended method. Let's stop the debug. So what's the solution? Go with the dense mode. So I'm going to first of all
Yes.
remove the sparse mode. Sorry, dense mode. I'm going to first remove the dense mode,
Very
and then
nice. Very nice. Yeah.
I'll enable sparse mode.
No.
Enable config T interface. No, before that we need to do another test. Before we remove the dense mode, let us join a group member so that we will see whether multicast is working proper. I'm going to join this group from router 5 and router 8. So I'll go to router 5 and 8. I'll go to the loopback interface. Loopback interface is pretending like an application which wants to receive some multicast signals. So we don't have real application. We simply say IP IGMP join group. Actually, the application will do this. I'm going to say 239.1.1.
Okay.
Fine. Now on router 5 alone, I have joined the group. Let me try pinging now from router 1. I should get response from 5 because joined member is a 5. I should get response. You see, router 5 is responding. No one else will respond. But others are receiving, and pruning happens in all other branches. Pruning happens here, pruning happens here. Only 5 branch is really utilizing the bandwidth proper. Others are wasting. Others are simply wasting the bandwidth and
Yeah, that's
process.
interesting.
So I say repeat 10 times, so I'm going to get response from 10 members. As it is
Yes.
pinging, now let's go and join group on router 8 also. 8 router is not ready. It's there. Interface loopback 0, IP, IGMP, join group 239.1.1.1.
I
So
see.
I'm going to get
Nice.
response even from 8.
Very nice.
But R6 might have already pruned in that direction. Only when the table gets refreshed, the response will come. R6 table should get refreshed. Till then, you will not be able to get response. These are all the drawbacks of dense mode. You see, I configured like a minute before. Still, I'm not getting response. Oh, now it has come. So 5 and 8 are
That's
two
true.
members.
That's
But
true.
there is a delay, there is waste of bandwidth,
Yep.
CPU, etc. To avoid this, we have to switch to spats mode, and we will decide one
Right.
particular router as a
Dense
RP router.
mode, yeah.
We can make our 10 as RP.
There you go. No,
Why I'm doing router
beautiful.
10 as RP? Why not router 3? See, if I do router 3 as an RP, to go to any destination, it will go via router 3. Then you will get an impression that every packet should visit RP between source and group. To prove it is not correct, I am making router 9 as an RP, so that the group member and
Perfect.
source only will meet only once in R9. After knowing the S, G, after knowing source and group, they will find their own shortest path to reach between source and group member. Because going via router 9 will be a long path for router 7 to ping router 1 or router 1 to ping router 7. Going via router 9 is a long route. Or for router 5 to go via router 9 to reach router 1 will be a very long route. So it should find its own shortest path. So it uses RPF, reverse path forwarding. The group member will find the shortest path to reach the source using RPF, reverse path forwarding, in spats mode, which I'm going to show you. But the ping is going on. It needs to stop. Before that, let us go and check on our R8 show IP M route, multicast route table. What do you see here? We see here that this two address from R1 is the source of this group. So in R1 we have these three address 19.1, 1.1.1.1, 10.13. You see here 19.1 is here, and then 10.13 is here, and also it has got a loopback 1.1.1.1. So router 8 is not showing this upper path because there is no way router 8 is connected to the upper path. It shows this path and this path, which are the two possible paths to reach router 8. If you go to router 5, you will see these two, 10.12 and 10.13. Show IPM route.
Right.
We see here 10.12 and 10.13. We don't see 10.19. Yes, 10.19 is no way taking you to router 5.
Right.
Yeah. So this is what we call as S, G, source, for which group. And we are right now running dense mode. This is the RPF, reverse path forwarding. It says in order to go to 111, I need to go to router 4. Who is telling that? Router 5 is telling. Is it true? Yes, it is true. This is the reverse path it needs to take. And if you go and check on R4, R4 will check what are the paths to take to reach 111. Let's go to router 4 and type show IPM route. For the same network, the RPF is router 2. Router 4 says I'll go to router 2 to reach 1.1.1.1 or 10.12. Fine. Now, hope the router 1 has stopped pinging. It's still going on. Two more pings are there. This is 7th packet, 8th packet. See how many duplications. It is all because multiple paths. Dense mode is like that. So the idea in making R9 as RP is, let me take a sniffer. if I make this as an RP and inform everyone that this is an RP, the source will say, I am the source for 239.11. And R9 will also know that R8 is one of the group member and R5 is another group member. So now, when this group member comes to R9 inquiring about the source, R9 will say 1.1.1.1 is the source. So what happens is R5 using RPF, meaning it will check its routing table how to reach 1111, and it takes the shortest path to get the multicast feed. So only to know the source, it will go to RP. Later on, the path is going to be like this. We call it as shared tree. The previous one, what we did is source-based tree. Source was flooding. Here, RPF is used to share the information about the source and the group member so that the group member can learn about the source and find its own best path to communicate between source and the group member using RPF. So the role of RP is just to tell the group member who the source is. Once this information is passed on, then there is no more need for an RP. They don't always go through RP. That's what I want to show you. So do you have any question? Let's do one show now. Let's see how to do this. I'll go to router 1 and remove the previous configuration that we did. No IPPIM dense mode. Instead IPPIM mode and write memory. So this is the configuration for sparse.
No, this is great.
I'll paste it on 578 now. 7 5
Sparse mode.
All right, next is I would like to do the similar thing on the two interface routers like 2, 3, and 2, 3, 9, and 10. 2, 3, 9, and 10 has got here. So this is on router 2. Something is wrong. Uh-oh. Okay, 2 is done. 9. 2, 9, and 10. Fine. What is next is 3 interface routers are 4, 3, and 6. 4, 3, and 6. No, 6 has got more interface. 4, 3, and 1. 4,
Space,
3,
yeah.
and 1. 4. Okay. Now one last router, which is R6. It has got one additional interface. That's it. This is router 6. Now we have enabled PIM sparse mode, but what is missing is the main piece, rendezvous point, the meeting point. So the meeting point, as we discussed, we are going to make router 9's loopback address as the meeting point's address. Now this need to be informed to every router, either statically or through some protocol. Today we are going to do statically, and in our next session we will see the other options. Now, before we enable RP, if I ping now, I will not be able to
Right.
ping 239.1.1.1. I will not be pinging, and it is not
On the
flooded
RP, yeah.
nor prone. It won't even leave this router because this router does not know RP. Show IP PIM interfaces. If you see now, all are running sparse mode. If they're running sparse mode, they need RP. Show IP PIM RP. Hey, are you aware of RP? It says no. I don't know anyone called RP. So the packet won't even leave. So there is no wastage of bandwidth or processor. RP is mandate. So I'm going to make R9 as RP. IP PIM
Right.
RP address 9.9.9.9. Now before I
Mm.
okay, no problem. I hit enter. Now this is RP, but no one knows that this is RP. As a result, if I type now show IP mroute, you don't see anyone coming and enrolling. This is default. This is auto RP. Our address is not 224. Our address is 239.1.1.1. So far, no one has inquired. So far, no one has come to RP asking for 239.1.1.1 because the group members are R5 and R9. Sorry, R5 and R8. We have not configured RP there. Sorry, we have not informed who
Mm-hmm.
the RP is. So how to inform who RP is? The command is the same command that I did. The same command that I did under the on the RP router. I need to put in all router. The command that same command, same IP. Don't change the IP. So I need to tell every router that this guy is the RP.
Mm.
Now, if I go to 5, let's go in order. Router 1, router 2,
Oh, hold on. Just static. Yeah. Gotcha.
Now,
Yes.
after I finish pasting this, you will see a surprise. What is that? Router 9 knows about the group members. If you go to router 9 and ask now, show IP M route, you can see here there is a request coming on Ethernet 00, this interface. There's a request coming on this interface. If you come on this interface, who might have requested? It may be router 5, because router 5, 1, 2, 3, 4 hop. For router 8, 1, 2, 3, 4, or 1, 2, 3. For both, this is the same path, same cast. Let's see, is there any other interface? Okay, two interface. There are two requests. One in this direction, so which is router 8.
Yes.
Router 8 has requested. Router 5 also said, I also want any traffic that is coming to the server. So both have already informed RP that we are interested in this traffic. So R9 knows that if any traffic comes to 239.11, it needs to be sent only on these two interfaces, not other interface. So in this topology, I have only two interfaces. If we go to router 3, you will not see this info. Go to router 3 and see. Show IPM route. In router 3, you don't see for 239. Okay, there's one exit. Okay, it goes to router 5. Router 3 says I can forward to router 5. Okay, but router 7 won't have any info. Because router 7 is no way connected to group member. Router 7 has got no info. Router 6 will have only via this direction, G02, E02, because there is a receiver. It says E02 is the only direction I need to flood it, no other direction. I'll receive on E01, which is this direction you see, it is going to RP right now. I'll receive on E01 and I'll send it to send it out via E02. But after I ping from here, this will change. Why? For router 8, going via router 9 and 10 is not a feasible path. So incoming interface, after I ping, I'll come and show you on R6, this will be 00, not 01. That is to prove that the reverse path forwarding is working. Let's see that. Now I'm going to go to router 1 and try pinging 239.101. I'll get the response from both 5 and 8. 5 and 8. 5 is responding and 8 is responding, but this time it's not flooding and pruning. It is only sent to the appropriate. Now let's go to router 6 and I want to show you what I was talking. Earlier the incoming interface was 01 if it comes from RP, but I am telling you it will not come from RP because source is here close to R6, R3. So now the incoming should be 01. Still 01. If it comes via 19, it is 01. What if it comes via 10, 13? 00. All traffic coming from 10, 13 will be taken in this direction, given in this direction. This also, all traffic coming from the loopback is also taken in this direction because the RPF finds that this is the best path. This may disappear after some time because this is more hops. Yep. So it takes the shortest path. It is not going to go always via the RP. Okay, for example, on R5, if you see, on R5, it will not go to R9. How will I prove that? R5, let me go to router 3. No, anyway, it will go to R1. Okay, let's go and check in R1. show IPM route. It says for this I have only two
I
outgoing
see.
interface, which is down interface. Another one is this interface. So whatever goes in this direction goes to router 5 and also to router 8. If it goes via this way also, it can go to router 8. Anyway. So this is spats mode. No flooding. It knows clearly on which direction. See, it did not send on G0, E00. Whereas the dense mode will flood on every interface. Nice, correct. Right. Okay. So we'll stop here.
Mm-hmm. Right. Every interface, yes, very noisy.